The final chapter offers a step-by-step virtual tour that allows readers to imagine experiencing an entire ISS mission. It begins with astronaut training, followed by launch aboard a spacecraft such as the SpaceX Crew Dragon or Soyuz. Readers experience docking with the ISS and entering the station through its airlock. The chapter guides readers through every major module: laboratory, sleeping area, exercise room, dining area, observation window, and research facility. It describes the sensation of floating in microgravity and witnessing spectacular views of Earth from the cupola. Readers also observe astronauts performing scientific experiments, operating robotic systems, conducting maintenance tasks, and communicating with mission control. The virtual journey concludes with preparations for departure, undocking, atmospheric re-entry, parachute landing, and post-mission recovery. The chapter ends by reflecting on the ISS as a remarkable achievement that demonstrates humanity's ability to explore space through science, innovation, and international cooperation. This chapter explores the ISS as an outstanding example of international collaboration. It explains the roles of NASA, Roscosmos, the European Space Agency, the Japan Aerospace Exploration Agency, and the Canadian Space Agency. Each partner contributes modules, technology, astronauts, funding, and scientific expertise. The chapter highlights how scientists from around the world collaborate on research that benefits all humanity. It also discusses educational programs that inspire students to pursue careers in science, technology, engineering, and mathematics, also known as STEM. Finally, the chapter examines the future of the ISS, including plans for commercial space stations, private space companies, and preparations for missions to the Moon through the Artemis program and eventually to Mars. This chapter explains how astronauts maintain and upgrade the ISS while orbiting Earth. It begins by describing extravehicular activities, EVAs, commonly known as spacewalks. Readers learn about the extensive training astronauts undergo before leaving the safety of the station, and the specialized spacesuits that protect them from the harsh conditions of space. The chapter discusses common spacewalk tasks, including repairing equipment, replacing batteries, installing new scientific instruments, and assembling station components. It also introduces the Canadarm2 robotic arm and the Dexter robotic system, which help astronauts move heavy equipment and capture arriving spacecraft. Readers gain an understanding of how continuous maintenance keeps the ISS operational and safe, despite constant exposure to radiation, extreme temperatures, and tiny space debris. This chapter examines the ISS as one of the world's most advanced scientific laboratories. It explains why conducting experiments in microgravity allows researchers to observe phenomena impossible to study on Earth. Readers learn about medical research investigating the effects of spaceflight on bones, muscles, vision, and the human immune system. The chapter also discusses biological studies involving plants, microorganisms, and animal cells. Other topics include materials science, fluid dynamics, combustion research, Earth observation, climate monitoring, and technology development. The chapter explains how discoveries made aboard the ISS contribute to improvements in medicine, engineering, agriculture, and environmental science. Finally, it explores how ISS research supports future human exploration of the Moon, Mars, and beyond. This chapter focuses on what life is like aboard the ISS. It explains how astronauts adapt to living in microgravity, where ordinary activities such as eating, sleeping, exercising, and even brushing teeth become unique experiences. The chapter describes astronauts' sleeping quarters, which are small private cabins equipped with sleeping bags attached to the walls. It explains how food is specially prepared and how drinking water is carefully managed. Readers learn about the station's advanced life support systems that recycle water and produce breathable oxygen. Hygiene practices, clothing, and waste management are also covered. The chapter discusses astronauts' daily schedules, including scientific experiments, maintenance tasks, exercise routines, educational outreach, and communication with family on Earth. It also highlights the psychological challenges of long-duration space missions and the importance of teamwork and mental well-being. This chapter serves as the main tour of the ISS by introducing its various modules and their purposes. Readers begin with the Harmony, Unity, and Tranquility modules, which connect different sections of the station and provide living and working spaces. The chapter then explores laboratories such as Destiny, United States, Columbus, Europe, and Kibo, Japan, where astronauts conduct hundreds of scientific experiments. The Russian segment is also discussed, including Zvezda and Nauka, which provide life support systems, sleeping quarters, and research facilities. The chapter explains the role of solar arrays, radiators, communication antennas, docking ports, and airlocks. It also introduces the famous Cupola, a 7-window observation module where astronauts enjoy breathtaking views of Earth and monitor robotic operations. By the end of the chapter, readers understand how each module contributes to the ISS's daily operations and scientific mission. This chapter explores how the International Space Station came into existence. It begins with the history of early space stations, such as Salyut, Skylab, and Mir, which laid the foundation for the ISS. The chapter explains how the Cold War rivalry gradually transformed into international collaboration. In the 1990s, multiple space agencies agreed to develop a single orbital laboratory. Construction officially began in 1998 with the launch of the Russian-built Zarya module. Readers learn about the assembly process, which required dozens of space shuttle missions and rocket launches. Astronauts performed numerous spacewalks to connect modules, install solar arrays, and assemble the station piece by piece in orbit. The chapter also discusses the challenges engineers faced, including transporting massive components into space, connecting systems built by different countries, and ensuring astronaut safety. It concludes by highlighting major milestones in the ISS's construction and its evolution into the largest human-made object in space. This chapter introduces readers to the International Space Station, ISS, one of humanity's greatest engineering achievements. It explains what the ISS is, where it is located, and why it was built. Orbiting approximately 400 kilometers, 250 miles above Earth, the ISS serves as a permanently inhabited laboratory where astronauts from different countries live and work together. The chapter also describes the ISS as more than just a spacecraft. It is a symbol of international cooperation. Countries including the United States, Russia, Japan, Canada, and members of the European Space Agency combined their expertise and resources to create the station. Readers are introduced to the station's basic characteristics, including its size, speed, orbit, and the experience of microgravity. The chapter also highlights the ISS's role in scientific research, technological innovation, education, and preparations for future missions to the Moon and Mars. It concludes by explaining why a virtual tour of the ISS is both educational and inspiring.